Hi everyone, Assalamualaikum. In this video, we are going to discuss example 2 under homogeneous equation second order ODE for repeated roots. Okay, solve the second order homogeneous equation y double prime minus 2y prime plus y equals to 0. Equals to 0 here means homogeneous equation and y double prime here means under second order ODE. Okay, and there is no initial condition, so we no need to find the values of C1 and C2. Okay, and to solve homogeneous equation, first step we need to find the characteristic equation. Alright, how to find the characteristic equation? Okay, first we write y double prime equals to m squared. Okay, y single prime equals to m. M here means m to the power of 1. And we write y equals to 1. 1 means m to the power of 0. So y double prime we replace by m squared. Y single prime we replace by m to the power of 1, which is m. And y we replace by m to the power of 0, which is 1. So we get m squared minus 2m plus 1 equals to 0. This is characteristic equation. And at the same time, this characteristic equation has degree 2. So it means that this is also quadratic equation. Okay, after that, we can continue with step 2, solve the quadratic equation. Okay, let's say if the solution is complex root, we never use calculator. Okay, if the solution is complex root, we need to use quadratic formula. Okay, in this question. Alright. Alright, so from here we can factorize. So this is not complex root. Okay, but this is repeated root. Okay, because m1 equals to m2. Okay, which is equals to 1. Alright. Alright, we also can find the value of b squared minus 4ac. If we substitute, b equals to negative 2, b is coefficient of m, and then squared minus 4 times a means coefficient of m squared, and then we replace c means constant, so we get b squared minus 4ac equals to 0, means that this is repeated roots. Okay, you can find the value of b squared minus 4ac, or you can also factorize. Okay, and from the answer we get repeated value, so that m1 equals to m2, so it means this is repeated roots. Okay, we don't need to find the value of b squared minus 4ac. Okay, from the answer we also can make conclusion this is repeated roots, right? Okay, after that we continue with step 3. Okay, write the general solution based on the types of root. Okay, from here the types of root is repeated. Okay, so we can write general solution y equals to c1e to the power of mx, okay, plus c2x e to the power of mx. This is the formula for general solution for repeated roots. Okay, then we replace m by 1. Okay, so we get c1e to the power of 1x plus c2x e to the power of 1x, or we just write x only. Okay, alright, the initial condition is not given, so this is the final answer because the initial condition is not given, so we no need to find the values of c1 and c2. So when the initial condition is not given, the step is so simple, for homogeneous equation under second order ODE. It is totally different compared to homogeneous equation under first order ODE. Alright. Now we continue with example 3. This is for complex root. Okay, solve the second order homogeneous equation y double prime plus y equals to 0. Y double prime here means second order ODE, and equals to 0 means homogeneous equation. And to solve second order ODE homogeneous equation, first we can write y double prime plus 0y prime plus y equals to 0. We put 0 for any missing derivative to avoid error. Okay. Then step 1, we find characteristic equation. Okay. Which is m squared plus 1 equals to 0. Okay. Y double prime we replace by m squared. Okay, here. Y prime we replace by m, which is m to the power of 1. But there is no term containing m. So that's why we get 0m here. Okay, no term containing m. Okay, and then plus y. We replace y by 1, which is m to the power of 0. So y here means 1. Okay, and then equals to 0. Right? And this is also quadratic equation because the degree of m equals to 2. Right? And to solve quadratic equation, okay, if we cannot factorize, we can use quadratic formula. Okay, so we solve quadratic equation. Okay, if the solution is complex root, we never use calculator, but we need to use quadratic formula. Okay, in this case, there is no term containing m, so we can write m squared as a subject, which is equals to -1. Then we write m equals to, we move square to the right hand side, so we get square root. Yeah, square root of -1 here. And square root of -1 actually equals to I, means imaginary numbers. Okay, so because there is term containing I here, containing imaginary numbers here, so means this is complex roots. Okay, then we can write m equals to 0 plus minus 1i. Okay, because we need to find alpha and beta. So when we compare, okay, m equals to alpha plus or minus beta I, we get alpha equals to 0 and beta equals to 1. Right? We can also solve this quadratic equation using quadratic formula. Before that, we can find b squared minus 4ac. Then after we substitute the values of a, b, which is 0, and c into b squared minus 4ac, we get b squared minus 4ac less than 0, which is complex root. Okay, then we can find the value of m using quadratic formula. Okay, so from this quadratic formula, okay, after we simplify, we get m equals to 0 plus minus 1i. Okay, why we write into the form of 0 plus minus 1i instead of I only? Because we want to compare and we want to find the value of alpha and beta. Okay, to substitute into general solution formula. Alright? Okay, after we find the value of alpha and beta, before that, for complex root, okay, we need to find the value of alpha and beta. So to find alpha and beta, we need to write m in terms of constant and then plus minus constant I. Okay. Then we continue with step 3. Okay. Write the general solution based on the types of root. Now our types of root is complex root. Okay. So we can write general solution based on this formula. Okay. For complex root, okay, the solution equals to here. Okay, so we can write y equals to e to the power of alpha x times c1 cos beta x plus c2 sin beta x. Alright. Then we replace alpha equals to 0x, alpha equals to 0, and then times x, c1 cos beta equals to 1, so we write 1x plus c2 sin 1x. Okay, and e to the power of 0 equals to 1, and 1 times any value equals to that value. Okay, so we have y equals to c1 cos x plus c2 sin x. Okay, Then we double check. The initial condition is not given here. Okay, so this is the final answer because the initial condition is not given. So we no need to find the values of constant C1 and C2. Okay, but if the initial condition is given, after that we need to find the values of C1 and C2 by finding Y single prime first. Okay, because the initial condition for second order ODE, we must applying the given initial condition X, Y, and Y single prime. Okay. Is my answer correct or wrong maybe? We can check the final answer. From the previous slide, we have solution y equals to c1 cos x plus c2 sin x. Then we differentiate. We get y prime equals to, we still have constant c1 here. Then we differentiate cos x, it becomes negative sin x. Plus c2, we differentiate sin x, it becomes cos x here. Then we differentiate again. Okay, because we want to find y double prime. Okay, because from the given question, we have y double prime here. So when we differentiate y prime, so we get y double prime. Then we still have negative c1 here, the constant. Then we differentiate sin x, we get cos x. Okay, and then plus, we still have c2 here. We differentiate cos x, it becomes negative sin x. Okay. And after that, we substitute y single prime and y double prime into the given question. Okay. From the given question, okay, we replace y double prime by negative c1 cos x minus c2 sin x and then plus y. Y means c1 cos x plus c2 sin x. After that, we can simplify negative c1 cos x and positive c1 cos x. It equals to 0. And we can simplify negative c2 sin x plus c2 sin x. It's also equals to 0. Means that our y double prime plus y equals to 0. Okay? And when we compare, okay, from here, it is exactly the same. So means that we show that when we differentiate and when we substitute into the given question, we still have the same equation. Okay? So it means that the final answer is correct. Okay? Right? Coming up next, non-homogeneous equation. If you like this video, you can subscribe. Thank you for watching. Stay tuned. Bye. Assalamualaikum.